25 years ago, I stepped off the bus at 11 o'clock at night. I was 15 years old, and it was my first and my last time in St. Louis. It was dark. I'm 15, and I just spent 2 days on a Greyhound bus going from LA to St. Louis. This was 1999. There was no cell phones. There was no internet for me. I had some quarters and my friend's home phone number, because that's all we had was home phone numbers. And I'm looking for my friend's mom, who I hadn't met for a year, because she was supposed to pick me up. But all we coordinated was, hey, I'm leaving from LA on this date, and I should be to you 2 days later. Can you pick me up? I was surprising my friend for spring break. He didn't know I was coming. And I was like, this is a great idea, right? Like I'm 15, it's spring break. He moved out, and so I'm just gonna buy a ticket in LA. It should be fine. This, I can see on the map, it just goes straight there. The bus will take me. I didn't have a license or anything. So I thought that would be okay. It turns out on a bus, there's people that aren't always the kindest people. They're not always the most social people, and there's some detours along the way when we're on a bus for 2 days, when the driver hits an owl, and when we pull over so someone can get arrested, and all of those fun things that you experience when you're 15 years old with no one that for thousands of miles in either direction. But I made it, and I surprised my friend in his room at 1 a.m. and just showed up and said, hey, how's it going? And he's like, what are you doing here? I was like, surprise, I'm here for 2 days, and you're taking a bus back with me to LA. And when we left, there was a tornado warning. So yeah, that was the last time I was in St. Louis. It was a lot of fun. So I'm glad to be back. And a lot of that journey taught me, you can't really you can't expect anything from a map, from any sort of roadmap. And when I was thinking about it, I was like, that was basically my roadmap into Kubernetes. 2016, I had a Jira ticket that said developers want to self-deploy applications. Our web developers, we're on-prem. They're like, we want to self-deploy. We don't want to send emails or open Jira tickets. We just give us a way to self-deploy. And in 2016, I'm like, well, this Kubernetes roadmap looks pretty good. There wasn't a whole lot, but I could see from where we were at with VMware and Puppet to this roadmap of Kubernetes land. And I'm like, we'll get there, right? So we spun up our, oh, wait, I gotta turn this on. It's not even on. Do we get light?
There we go.
There's the lights.
Change angles here. That light is beautiful.
You're gonna have to dim these lights. Well, if I turn it on, we might actually dim the lights. Let's hear one beep. We gotta make sure it all. I heard 2 there. Waiting for the 4th. Every time I travel, something happens. I didn't hear it, but I don't know which one it would be. We'll figure it out. All right. I know, right? And that was when we were creating this Kubernetes cluster, we're like, well, what do we have? We have some servers in a data center. How do we build it? And so literally I was just like, well, let me try this thing. They gave me 6 servers. These are throwaway boxes. No one wants them anymore. They were too old. So here, you can have them to do whatever you want with. I was like, cool. I'll take them and we'll try this. And 2 weeks later, we actually had a Kubernetes API available. And I was like, wow, this is kind of amazing. And I did it all wrong, and that's okay. I started with CoreOS at the time. If anyone used CoreOS back then, came with an internal etcd database to figure out which nodes could reboot. And I was like, well, I'll just use the database that's there. What can go wrong, right? It's a database. It's fine. They'll use it sometimes. Machines will reboot, but it'll be okay. And so I start creating this Kubernetes cluster, and the first time I kube control apply something, it deploys and it just returned to my shell. I'm like, well, I just got back a prompt. What's going on? Something is broken. And turns out it actually was working as expected, and it was just faster than I ever had seen anything spin up before. And I was like, oh, that worked. Are you kidding me? And so it was kind of amazing, because once that was there, I'm okay, now I really understand what we can do with a system that's designed around a container versus a VM with automation and sort of this declarative state. All this stuff started making a little more sense. And then I spent the next 3 months integrating that one handcrafted system into the rest of our data center tooling, DNS, server provisioning, networking, the data inventory database, all that stuff. It took way longer than the Kubernetes piece of it. I'm like, okay, I understood that. Until we finally got the Kubernetes cluster deployed. And let's see if we can't pull this over. If you were around in the 2000s and remember the Mac cubes, they were pretty awesome.
Nice.
So we finally got deployed, and I don't know, maybe I can see which one's not running, but it's okay. Let's see if we have an API. I don't have an API. So the one that didn't come up is the API server. Oh, and one of my solders broke. That's okay. Should be online. Give it another second. If not, we'll reboot. Let me also double check my network is available, because it would need internet, or at least some network connectivity for me to see if it's available. I didn't hear a beep though, so maybe it was already running. Dang. All right, let's see if we can do a little bit of troubleshooting. This is that hardware aspect, right? Like, oh, that one, you're not on. Which one are you? Here. There you go. And I can, let me mirror my screen too. Aha, there's the fourth beep we were waiting for. That was the API server. And mirror. And for the second trick of the talk, we have dual monitors working in Linux. All right. Okay, that'll take a minute to boot still. So we were starting out, and even at the time, back in 2016, everyone's like, systems need to be cattle, not pets. They need to be crops, not houseplants, whatever you want to say for, however you want to treat it, you're like, we shouldn't care. But I absolutely guarantee you that hardware on-prem, it matters. And you can't just pretend that this is just a thing that we can throw away. I still remember the name of the 6 nodes that were my Kubernetes cluster from that all that long ago. And I remember it because at the time I was working at Disney Animation and we were working on Moana. And so it was Maui, Tui, Hey Hey, Teppo, Pua, and Dumbo for some reason. And so those were the names of the machines. And once you give machines names, like, they matter and you can't just throw them away. And I guarantee you that with those names, Hey Hey gave me the most trouble. If you've seen Moana, you know that Hey Hey is just dumb. And that machine constantly had problems.
Is that what you named it?
They gave them to me. They were already pre-named. I didn't even get to pick the names. What? Let's give it another minute. But people wanted to treat machines as disposable, and on-prem, that's not how it actually works. And the more you try to fight that system, the more roadblocks you're going to hit in that journey for whatever you're setting up if you're on-prem. Even Kubernetes clusters now, people say they should be disposable. But once you tie anything on the outside to it, pointing in, whether that's storage or DNS or ingress or load balancers, whatever it is, the thing matters now, and you can't just throw it away. And so this constant back and forth, people are like, well, I don't want to care about it. Well, too bad. Like, you're the one that set up your host name for your website points to this thing, and now you can't just throw it away because DNS propagation, all of that stuff matters. And so the more I found that people were fighting against that, especially on-prem, it was like, okay, we have to just get over the fact that why won't this work? That's the thing we have to get over. Let me double check. Wait, why else might this not work? I have network. I have network, right? Yes, I have network. And I'm attached to my thing. So this has network. I think I exported the right kube config.
And I did want to make a complaint. You said cube config or cube control and not cube cuddle. Yeah, it's like a chip versus game. Right. I know with CNCF, they're like, it's cube control. It's like, I can't do that. It's cube cuddle. It's always been cube cuddle.
It's K for me. It's just the letter K. Many letters.
Let's do a little more troubleshooting here.
So would it be system cuddle as well?
I actually said system cuddle.
The only one that's not is ioctl is not. Okay, let's double check this. Look at that, nothing ready. Booting. It's gonna be a short talk. And one of the hard drives did pop out when I was flying here, so let's just try rebooting it all. Okay.
Yeah, and that's a serious case that you use for that transport.
Yeah, I shipped it once. Actually, after KubeCon last year, a coworker shipped it back to me, and I didn't put padding inside the case, and all the plexiglass that was cut all broke. And so it came, and the whole thing was just like rattling inside. I'm like, that's going to be not a fun situation to figure out. So, but one of the things, so like on-prem Kubernetes, it like once you have it set up, it mostly works, and you can just run it. The problem then becomes you have this like friction with like maintaining things on-prem, because a lot of on-prem servers, like you set it up and it lasts for as long as the hardware lasts, and then you just throw it away. Right? It's like it was purchased on a plan based on a budget from 3 years ago, and that's going to last for 5-ish years, and then who cares, right? Like that's the runway of the thing, and you don't really maintain them necessarily as much. Like you're not reinstalling them every year. It's not like the cloud. And if I switch over just to show, nope. Make sure that I actually can connect to AWS. Okay, at least that one's working. See, the cloud's more reliable. You should just do it. Still not there.
I love the name Kubernetes.
Kubernetes, yes. And that was when we were planning it. I actually was going to build the whole system in a Mac 2 and put like in the screen, have like a display. And then one of my friends was like, my coworker was like, "Oh, do you remember the old cubes?" I'm like, "That's it." I was like, it has to be that. And then everything just, I bought it used online. And I'm like, everything has to fit in here. And then I started getting crazy with adding lights and the switch and everything else. So let's do more. Okay. Anyway, but like you have it on-prem and people say, great, like it's going to work. But a lot of companies, they're like, we want to go on-prem with Kubernetes first so we can go to the cloud. Like it's like their stepping stone. They're like first stop on their roadmap to, we want something in the cloud. We want it to be fully scalable, whatever. And one of the things that most people would think is, hey, it's going to be the same because it's Kubernetes and it works in both places and it's portable, right? And I'm here to let you know that it's not. This is the manifest that creates the cluster. It's built on Cluster API, which in my opinion, is the open stack of Kubernetes. It is in a bad way. It is overly complex and it tries to do a lot of things, and it's not meant for end users. It is meant for larger scale builders. And it's similar to exposing Kubernetes directly to developers, where you don't usually want to do that because there's too many abstractions, there's too many knobs, there's all these things that you don't usually want to give people. And in this case, this is the EKS Anywhere config, which is based on Cluster API, which we simplified as much as possible to say, okay, well, you're not going to deploy any other providers that we don't support. You're not going to use every knob. Let's try to trim that down to make it easier for you to use. And even in this case, like a bare metal provisioning, we use a tool called Tinkerbell, and that's the only way we allow you to pixie boot it, because that's what we support. On the flip side, if I look at something like a EKS in the cloud config, this is using CloudFormation. And although it's YAML, it actually looks nothing like the other config. And a lot of people try to treat it the same, and they try to say, well, I'm going to shoehorn these two things into the same workflow. And at the end of the day, they just end up with completely different stacks for cluster management, because everything is different on-prem and in the cloud, where my storage, my networking, my load balancers, my annotations that configure all of those things, they're all different when you're on-prem versus you have a full cloud provider, which is like, oh, I don't need to rely on my F5 on-prem. I can rely on the AWS load balancer for a service. All that stuff becomes a problem. But the bigger problem usually ends up being the cost model, where if I want to, say, scale this cloud instance, there's no auto scaling on-prem. Have you ever tried to do auto scaling? I know plenty of people that are like, oh, I'm going to do it with VMs. I'm like, why? Like, you still have just the hardware, like you're still bound by how much power your data center and how much cooling your data center has. But if I want to, say, scale up, in the cloud, EKS node, there's my 2 nodes right now. I have Carpenter running that sees those 100 pods as they're coming in. You can see there's 112 pending, and it'll create nodes for me, and it automatically mounts the drives and it automatically provisions them with user data. And I didn't have to send an email or unbox anything or wait 3 months to get something to show up at my door. And however many nodes are needed is what gets provisioned. And the cost model in the cloud is based on however much you can consume. It's not this model where I wrote, decision docs on why we should purchase this, how much it was going to cost, every component that was going to go into it, the budget that I needed for it. And on-prem, my cost model becomes like, how much can I utilize it over its lifetime? Not on this side, how much can I optimize what I have already provisioned? Those are like, you're attacking the same problem. If you've been running anything in a cloud environment, you're probably doing some sort of like cost optimization right now. Like, you're like, hey, we need to spend less money on X, Y, and Z. You're trying to bring the cost down and provision less stuff. And in this case, you're trying to utilize the stuff you already have more. They both end up around the same spot, but the way you attack them are completely different problems. And again, that roadmap of we're starting here and we're going there really depends on how you're going to get there and in that path you're going to take. So it's not as easy as just, I'm going to use the same thing. It's Kubernetes. I'm going to use Kubernetes all day, every day, from everywhere. And that's what one of the main things I wanted to talk about was I really wanted that to work. Yes. It's the most expensive Rickroll you've ever seen. Because the other aspect of this is how do you do upgrades? Because in the case of the cloud, Amazon, if you're running EKS, we run the control plane for you. Like, you don't have to worry about that. It's a great value add for you, not needing to run etcd, not needing to run all these, auto scaling your API servers, all that sort of stuff. But the contract there is you have to do upgrades. We have a set of API servers that we can support, and you have to stay within that set. So you're going to be doing upgrades 3 times a year. And if that's not the contract that you want to be in, then the on-prem option of, hey, I don't want to upgrade this ever, I'm going to own that stuff so I don't ever have to upgrade it, might be the solution for you in some cases. If we, anytime you, anytime you're going to upgrade a system, it changes from where it started. So if we go to the upgrade image there, it's going to take a second, but you're going to see that as those upgrades go on, like the first time I did an upgrade for on-prem, like I was like, okay, it worked, but then I actually got a customer, right? And that was like the time that I was like, oh, now this is tricky because I can't just tear it all down and redeploy it, and you're not redeploying it golden every time. And even in this case, I now have how many nodes? 100 nodes. Like I wouldn't want to do an A/B cluster splits, because if I say I want blue green, which a lot of people are like, well, just do blue green. It's like, well, now I need 200 nodes. You're now running twice the cost while you migrate these workloads over. And if you've ever run infrastructure and you have a lot of teams and developers that depend on your infrastructure, at some points, some of those teams aren't going to be able to move. They're going to have reasons they can't because they have priorities and whatever. Did my upgrade go through? Not yet. Okay, it's still going to take a little while to pull it down. But all of those things end up being a problem for you because you're running double the infrastructure. So the real solution is to do in-place upgrades. Also because all that other stuff you can't treat, it's not cattle. Use load balancers, DNS, OIDC endpoints for authentication. You can't throw all that stuff away because you have to tell everyone in the company, oh, hey, change all your Jenkins jobs to go point to this new cluster. Like that's not going to fly. So those are all things that will get you on that path to Kubernetes. Oh, geez. Oh, you know what? Well, that would be why.
Is there a typo?
Yeah, it is.
Upgrade.
Upgrade. See? Did it go? Yeah. See, that's what upgrade looks like. And then, like the very end of it, right? Like some people say, I'm gonna burst. I'm just gonna use the cloud. It's gonna be a different system. I'm gonna keep on-prem. We're gonna do a majority on-prem. We're gonna burst in the cloud. Completely viable option if your business model and funding model supports that. At Disney Animation, it was the best business model for bursting to the cloud because we would send a terabyte of information to render a picture. And our input was a terabyte of, please ingest this. We're going to cache the stuff, and we get back a 2 meg JPEG, basically. And like that was a great business model because we could use the compute, we could use the storage, and then we could just throw it all away because we got the artifact that we wanted back. Shipping a movie turned out to be very different than shipping Disney Plus. Those were the two areas that I worked on at Disney. And shipping a movie was box software. We had a date for the movie to go into a theater, and we worked backwards from that date. We say, okay, a month before the date, we have to have the movie done. 3 months before that, the story had to be done so we could render most of it. And 6 months before that, all the software had to be done. So I'm looking at, 10 to 12 months before the movie end date. I'm like, I need to be done with systems and software. And at the end, when the movie was shipped, we could turn it all off and we could start over. Every movie is its own little company, basically. They start from scratch in a lot of cases. You can build on what you were doing, but you don't have to carry it from one movie to the next. It's clean environments. Disney Plus, we had a date. We worked backwards from that date. And, when code freeze was happening, when systems need to be ready. But the ship date for Disney Plus was a service. And that's when the work started. That was when we couldn't take down the clusters anymore. That was like, hey, actually now, like, this impacts revenue. The other models, like we were done and revenue just comes in from people buying the box software, right? Like a Blu-ray disc is software. A JVM literally decodes. In the case of a service, you can't do those things. It's completely different on how that business model works. And I'm assuming, does anyone here actually have a data center or use anything on-prem? You have Kubernetes on-prem? Yeah, and like how you run that is going to be different teams. It's going to be different process to spin it up. And the environments, once you're deploying to it, are going to be very different than an EKS environment because of the spend models and the upgrade cycles. And so, what's that?
We hit the ceiling of the number of parts we can provision over there. That's the ceiling restricted by the resources available to us.
On-prem? Yeah, and that's the same thing here. Like I can't deploy, you know, like right, like this is there is a limit here. But the benefit, right? Like the other option here of like on-prem, when you're dealing with like high availability in this case goes down to the plugs, right? Like you have dual power supplies and you have dual disks and you have dual CPUs and everything is redundant so that you could lose parts of it. This is my single point of failure is the plug in the wall for this, even though it has 2 power supplies and 4 machines. But at the end of the day, like your city power probably is your single point of failure for a lot of that stuff. In AWS, like your failure domains are AZs. And you're like, oh, well, I have 3 data centers I can deal with, and I can move these things around between data centers. But then you have to deal with, where does my storage live? How am I accessing that storage? How am I sending data between those AZs? This cable doesn't cost me any extra money if I send no data over it or 2 terabytes of data over it. My AZ is self-contained here. In AWS, like that cost model matters. And you have to think about the system design differently. And it's not just hey, here's our roadmap, right? Like the point A to point B thing just doesn't seem to work nearly as well. And this is, I don't mean to like say don't use any of these systems. I run into this problem a lot when people think like, oh, it's Kubernetes. And so that's fine because I run Kubernetes on my laptop and I run it on-prem and I run it in the cloud. And the main thing here is like actually the system is different because of the cost models and the failure domains of the environments where it runs. And you really have to think about that.
That's the idea behind it. The adoption that if we can run it for on-prem, we can run the exactly same configuration like the cloud or wherever you want. Yeah.
Exactly. And that
transferred as is.
Not
if
you're on an unsupported version of Kubernetes,
right.
You're gonna have a bad time.
Yeah, and like I mean, when my first version of Kubernetes that I deployed was 1.3, and I stayed on 1.5 for a really long time because 1.6 introduced RBAC. And I'm like, I wasn't ready for RBAC. Like I did not want RBAC in my system yet because we didn't have anyone else managing it. We didn't have anyone else with expertise there, and RBAC in 1.6 was really rough. So like all of that stuff, like, hey, we were able to stay back with the old hardware because we weren't ready to move. When you go to a hosted model, you have to move with what they are telling you, whether that's during a new application deployment or a movie deployment, whatever. Like you have to at some point upgrade that because AWS as a provider, we can't support more than so many versions across all of these clusters and customers. And yeah, that's the thing that we hear a lot as we were building EKS Anywhere. Like we just want EKS on-prem. I'm like, well, do you have S3? Do you have AWS load balancers? Do you have EC2? Like none of that stuff actually exists. And so we had to bring as much as possible, but really it came down to the bare minimum. Like what is the bare minimum you can provide on-prem that would allow you to get up and running? And then it's a matter of how do we shift that going forward? How do we help other people maintain that? And cluster APIs, the way we're doing it, which helps with if you have lots of clusters. But I don't know about you, like on-prem for us, like we had 1, maybe 2 clusters. I didn't need dozens and dozens of management. I didn't need, like the Terraform I write for EKS is a lot different just because I can create as many as I want. Like I'm not limited.
Clients don't want to be locked into the vendor, so they want to go with either multi-cloud approach or the hybrid of this on-prem and the cloud together.
And I hear that a lot too. Like Kubernetes is portable, right? Again, I can go across clouds. And the reasons that falls apart is you end up being like least common denominator for all those things where
the bare minimum common functionality.
You take on more ownership because you are now, I'm going to fill in the gaps for the cloud. So you're going to run your own Nginx ingress controller and just rely on the bare essentials load balancer. And you're just going to have to run that everywhere instead of saying, oh, actually like load balancers are a good thing. And it'd be great if like a cloud provider just did that. But the configuration is different. The controllers that you run inside the cluster are different. And it ends up adding more ownership into the cluster, which then makes it harder to upgrade. Because then as Azure needs one version and EKS needs another version and On-Prem needs another version, your ingress controller is this huge matrix of that sucks. Like that's all it says.
I'm not sure if this Terraform or Ansible kind of these things can solve this problem.
So you can get away with like some things in Terraform or like any of these infrastructure as code tools. There are other tools that build on top of Kubernetes perform like GitOps that does it a lot better, like Argo or Argo CD. Some of those can help, but like it's still pretty painful.
Yeah. And GitOps isn't a full solution, right? Because that's like, hey, we will always apply the YAML that we're provided, but then you end up just duplicating a lot of that YAML. Like your infrastructure repo has 3 different subfolders for GCP, on-prem, EKS, and then it's just different. It's like, hey, I can copy and paste some of it, but someone needs to have the logic in their head of how those things are different between each provider. And then when a bug comes up, who owns it, right? Like,
They all have their own, because we run workloads across all 3 cloud providers, and they all have their own fun. They have they have similar upgrade patterns. They have similar components that are available, load balancers, etc. But like all of them have like little niches of like things that are unique to one cloud provider and other, like configuration management. So, like there's always something that you have to do with.
Yeah, sooner or later you're gonna hit that roadblock that if you are doing it perfectly for one of the cloud provider, exactly similar thing is really hard to replicate with the other one because they have totally different way to they have implemented differently, and it's going to be a differently for you. So there's no common interface that will exactly work for all of them.
Right, and the spec for what you deploy is gonna look roughly similar, where it's like, oh, I need API server, I need some endpoints, I need some of those things, but like all of the details matter. And what EKS provides for managed add-ons isn't available other places. What GKE provides for autopilot isn't available other places. What like there's all these things that are different. And if you just keep building for the lowest common denominator, you're like, I'm not getting the value out of the system, right? Like, well, why do I need this anyway?
And then if you're using the managed solutions, you wind up just having like your abstraction. Like if you're using Terraform, you build out a big module that says, my cluster management thing as your abstraction. And you say like, I have these particulars that are common to my cloud providers that I need, but then you're still maintaining like 3 or 4 different, sub-modules under that are like a specific configuration for GKE, with a specific configuration for AKS or EKS, like you still have to do all that work. So,
yeah, the complexity is going to exist somewhere.
Yeah.
And it's just who is the one that manages the complexity. And a lot of times that gets pushed off to the infrastructure team are the ones that manage the complexity because no one else wants to think about it. But they have to work with, the platform team that's like one layer above. They're like, hey, I get a Kubernetes API, but what else is available? What else is in here? And how do I know how this thing scales or falls over with AZ's, differences and availability, that sort of stuff. So it's like once the platform team's like, okay, I can give something a little simpler to a developer so they don't have to know all the Kubernetes, you're going to hit some other roadblock once you figure out where's the edges. And if you allow a developer to deploy anything they want without guardrails, they're going to deploy anything they want. And when we were building, Disney Plus was actually built on ECS. There was no Kubernetes there. And one of the best decisions we ever made was we said no stateful storage. ECS supports statefulness. We do not as a platform team. And we told them, we're like, hey, go put your state somewhere else outside of the cluster. And it helped more than we could have ever imagined because 2 weeks before we rolled out Disney Plus, we rotated all of the nodes in every cluster because of availability. We needed more availability, so we had to change the instance types. And we're like, hey, if we had to coordinate with any team, get your state out, like that would have, Disney Plus wouldn't have launched on time. And so we did it, like it's just 2 weeks before, like, okay, it'll take us about 2 days. We have a lot of nodes. just let them roll. And all the workloads kept going through. And that was like one of the best decisions we made as a platform team. We were like, hey, actually, we can't support this right now. And being able to tell no to developers and say, you either don't run here or you re-architect your app to store in a database. Like go to S3, I don't care. Just keep it out of the cluster. And that was an amazing thing that we didn't think of ahead of time, how well that would serve us going forward.
But the problem in that, with like a platform team solution, where you limit features is suddenly now you have a public interface that you have to interact with on both sides, right? Like, what you make available to developers, you're setting the contract there as to what can and cannot change, and you're saying like, I have certain expectations on my cloud provider or whatever services that I need to build as you have a hard reliance on the vendor. So like, that can also, in your instance, obviously it didn't cause problems, but like if you make poor design decisions, it cascades a ton.
Yes, absolutely. And I have lots of feelings about platform teams in general, where it is the new central IT, and that model makes sense for being able to centralize some of that stuff. But like it's just another roadblock, and it's just another area where a platform team might accelerate the team to start, but at some point they're going to drag the team down. And they're going to move slower because you're going to get too many requests and you add too many features. And anyone who's done config management in the past or templated anything, you'll find that the template for the thing is harder than the config, right? Like the Nginx templates in Helm is 10 times more complicated with every if statement compared to just writing an Nginx config. It's like I would much rather go read the man page, write the Nginx config, and then just ship that than give me, here's some same defaults to start, but then someone else needs this and someone else needs this, and you end up having an if statement for the entire thing. And yeah, that's what a platform ends up becoming if you allow everything.
And you described the old job I had.
Every old job is new. So it's a new title from sysadmin to DevOps to platform engineer or SRE, whatever.
Pivotal has its own flavor and support of KS, right?
Who?
Pivotal platform.
Yes. Well, Pivotal is their VMware right now. VMware has Tanzu.
Yes.
Yes.
So what I remember, they provide a solution. So you run that infrastructure on your on-prem VMs and everything, and you can just take it and port it to wherever you want.
Right. And a lot of times those providers will they do that work of complexity of like, hey, you built our APIs. OpenShift's the same way, right? So it's like you have Tanzu, you have OpenShift, you have all these layers above the Kubernetes piece for like, hey, you might be able to escape to the lower tiers, but really we want you to interface with our API. And you're basically hiring a platform team. You're hiring a team that can manage some of that complexity under the hood, where you deal with a slightly higher abstraction. And that is the same thing for like a hosted service, like a EKS, but we're not going one step above that, right? Like we're just, here's the infrastructure, we will manage the cluster pieces for you. And when you click upgrade, we will do the rolling upgrades and the scaling, all that stuff. In a Tanzu or an OpenShift, like, hey, we'll do the same stuff, but we're going to give you a higher abstraction for the developers typically, where it's like, oh, well, hopefully they can move faster than whatever your developers need. And that is a better solution, in my opinion, than having it on a team internally that deals with only your problems. Because the more custom you make your solutions, the harder it's going to be to change those later. And I can't tell you how many times I've went into any environments and the things that we're dealing with, that we're trying to get over, are the things that were great solutions 5 years ago. Like it was the perfect solution 5 years ago, and the technology changed and the problems changed and the people changed. And now it's like, oh, that legacy thing sucks. Like, how do we get away from that? But that's like when you pay for vendors, like, okay, is it Googleable, right? Can I go search for this? And any developer can go find the solution and not be hung up by the person who forgot to write the documentation or didn't upgrade documentation, whatever. Like documentation is part of the platform. And if those docs are lagging,
Do I have to go look at the source code to figure this out?
Yeah, like-
It's in 10 hours. Like,
Yeah. I just, was it last week? Yeah, last week I spent 2 days on a bug in upstream Kubernetes that I thought it was an Ubuntu problem. I was having a problem with actually logging. And I was like, well, it works on all these other systems, but not Ubuntu. And it turns out the systemd unit that Ubuntu uses for the kubelet has a period in it. And upstream Kubernetes never thought that systemd unit files services would ever have a period in them. So like once it saw a period, it was like, that's invalid. Like, what are you talking about? Like, the systemd allows this. Like, why can't I do this? I found the line. I'm like, this is it was 2 characters that they were missing. I was like, you need a colon and a period, and then we're good. And I was like,
it's the worst when you have to think like that for sure. I have a question. I have a bone to pick a little bit around EKS's upgrading policy.
Yeah.
So sometimes it can be very, very difficult to manage upgrades, for a variety of different reasons, right? Like some of the examples you gave earlier were being a platform provider for development teams internally or externally, and having dependencies that have problems. You have like an operator, or you have a particular image that has some deprecated in one version and contains the other.
yeah,
And you could be managing this over hundreds of clusters, right? And that suddenly becomes like untenable in a lot of ways, right? It becomes very, very painful because
Yeah.
then you're like always behind the 8 ball on like doing upgrades.
and it's not up to you.
Yeah,
It's
and you get angry emails from AWS saying like, "Hey man, we're gonna auto upgrade, we're gonna do whatever," and it's not a. But are there any tools that, or things that are available for AWS in terms of managing? Because I know you can manage your node groups, you can manage your EKS cluster, stuff like that. But like the internals for your cluster, like if I want to see like, okay, I have like all these EKS clusters, I have all these operators. Some of these have deprecated things in these versions, and all like I want better stable management of like the internals in the cluster, so that I don't get caught by surprise on like the EKS.
Yeah.
Are there things that are like available for that? Or?
So we are working on a feature. It's on our containers roadmap, and it's called readiness checks. And so you can look that one up. That's a ticket. We're actively working on it for before you click that upgrade button, we could look at what's being called in the API. And we know version to version what's going to be deprecated, what goes away, all of that stuff. So we could say, hey, it looks like you're calling this. You might want to fix that piece first. Whatever is calling this API path, we know what it is. You might know what it is. We don't know actually what's the workload, but we see it hitting the API. So readiness checks is one.
Yeah.
The second thing that is actually working upstream in Kubernetes is there's an LTS SIG now for long-term support. For upstream Kubernetes, like how do we support something more than 14 months?
It's hard.
It's very hard. And as a complex system with hundreds of nodes, and if you're doing hundreds of clusters, like you're at thousands of nodes, and you can't just say, yeah, sure, it should be fine. It's like it's okay. Right, like we'll just see if it works, right? And even testing in lower environments in a dev or a testing isn't a sure bet that production is never the same as those environments. It's a rough assembly of like it should work this way, but if
the development team does something different, or they deploy something slightly different, or configuration's different, or
yeah, absolutely. So yeah, those are the two things that I would say look for. And I could look up the ticket if you want to
that'd be awesome.
subscribe to it, because we are actively working on that one. But yeah, the LTS piece is the other one where it's like, okay, Kubernetes in general knows we need to solve this problem, and how do we? And really, it's always been about like backporting fixes, or like bug fixes and security fixes. We already, as EKS, we already backport more fixes than upstream Kubernetes, like because there are 3 versions basically, and I think we do 5 because we support 4 active with a 1 that we're rolling to and 1 we're deprecating, and so we patch 5 versions when a CVE comes out. Upstream does 3, and so we're already taking some of that management. But what does an LTS look like upstream? If that's 5 versions, then cool, maybe we could take what's happening upstream with those patches and then add 2 more. I don't know, but that's definitely something that we know everyone has that problem. You're not alone on how do I do those upgrades. And that's where the on-prem solution, I own this hardware, I already paid for it. This doesn't cost me any more money.
It's stable.
Yes, right. And your upgrade cycle is literally a blue-green. I'm going to buy new nodes and I'm going to create something new a lot of times. And that's when you can jump multiple versions, because the other problem with something like EKS is you can't go from a 3 version jump.
Yeah, you go one after the other, and there's a problem in that one, and you spend 2 days on it, and then you
Yep.
go to the next one, and
Yeah.
the same thing happens.
What are you using for node management? Are you doing managed node groups or Fargate or Carpenter or? Yeah. It's all of them vary, which is also a heartache on you of like, well, what's this cluster?
Well, thankfully it's not one.
Yeah.